Welcome back, everybody, to the Additive Snack Podcast. I'm your host, Fabian Alefeld, and today I am joined by Doug Woods, the president of AMT. If you don't know about AMT, you've probably heard about IMTS. IMTS is, if I'm not mistaken, the world's largest show around manufacturing. If I'm not correct, Doug will probably correct me as soon as we welcome him to the show. And therefore, Doug is the perfect person to give us an update of the overall manufacturing ecosystem. A lot is happening in today's world when it comes to manufacturing, not just around additive, but of course around innovations such as artificial intelligence, robotics, but also the macroeconomic changes that we're experiencing on a day-to-day basis. So therefore, today we'll talk about many different innovation and many different innovative topics, and we'll talk about different types of policies that affect each and every one of us. So therefore, without any further delay, Doug, welcome to Additive Snack. It's an honor to have you on the show.
So excited to be here, Fabian. I mean, this is one I've been watching from the background. Once in a while, your boss kind of pokes me and says I should pay more attention to what comes out in the podcast regularly, so I try not to miss too many. But really excited to come here and kind of just chat with you about things that are going on in the manufacturing space, which is a space I just love to live in.
Yeah, and I think, if I'm not mistaken, you not only yourself have a strong background in manufacturing, but your whole family history goes pretty far back into the tool and die space. So before we dive into what's going on in manufacturing and AI and all the other major buzzwords that are floating around here, let's start talking about you. How did you find your way into manufacturing, and how has your family history in that space influenced your decision-making there?
I actually really got lucky when it came to picking careers. It kind of picked me. So I didn't have to work too hard to figure out what to do when I grew up. My grandfather came here from Germany. He's from the Black Forest area in southern Germany. He came here in the early 1920s and started working at a tool and die company in Rochester, New York, which is my hometown. And he was working there probably 10 or 15 years, as he came here pretty young. At that time, he was probably just 20, 21. He worked there for about 15 to 20 years, and he and about exactly eight other guys, decided they had a better way to actually move the business forward. And so one day they all walked in and quit, and they started another tool and die company in 1947 in Rochester, which was a hotbed for manufacturing because Kodak, was in Rochester, Xerox from Rochester, Bausch & Lomb from Rochester, Gleason, Rochester. So it was a lot of manufacturing base in Rochester. And so a lot of opportunities. So that company that the 9 guys started back in 1947 turned into 1,200 employees and about 150 million by 1977. So 30 years later. And I then was lucky enough, as I grew up, to be able to work with a lot of the different divisions. So there was a division that was doing precision machining, a division that was doing machine rebuilding, a division doing mold making and molding, metal stamping and stamping production. So leak testing systems and an automation company. So part of my apprenticeship growing up was actually spending time in every one of those divisions and learning a little about each one of those different trades. And, just walking into then kind of a career that started at that point from, a lot of sharp people back in the day. So you're talking about, I started when I was 15, which was 1975. And I wasn't allowed to work in the shop floor yet at 15 in New York. So my grandfather decided that I really should start work. So I started in the tool crib, one of the facilities. And actually turned out to be a little bit of genius. I think Grandpa had a lot of genius in little things that he did that didn't seem to make sense at the time. But by starting in the tool crib, first of all, we wouldn't get in trouble with New York State laws of having me out where machines would cut my fingers off if I was being an idiot. But more importantly, at the tool crib, you learn about all of the things that the guys are coming to get. So what's the difference between a quarter 20 tap, cap head screw, all the different things, inserts, everything that they're getting, that they're using, all of a sudden became, normal vernacular. So you really learned a lot about the industry and got to meet a lot of the guys. So that's kind of how I started in the business. Did my apprenticeship on summers between school and college. And just a quick little funny story. When I graduated from Syracuse, and I came into work after that with a suit and tie to my first day of work after graduation and summer vacation. And I was waiting outside my grandfather's office to go like, okay, what's my new job going to be now that I've graduated from college? When he walked in, he saw me sitting out in front of his office, and he looked at me with this really strange look in his face, like, what are you doing? And I said, well, I'm here to start work now. I got my degree. I'm ready to get in the office and do some real work. He said, I don't know what you were thinking, but you still don't know anything. Go home, change your clothes, get back out, and go report to the foreman on the shop floor. He's been waiting for you. You're already late. That's needless to say, I spent a bunch more years doing stuff on the floor, quality engineering, manufacturing engineering, kind of just working my way up. But that's kind of how I got into the game.
That's awesome. Yeah, and it really sounds like you were exposed to all facets of manufacturing very early on, and very interesting also as part of an apprenticeship program, which for the Germans out there is standard when it comes to getting your feet wet in manufacturing, right? Most folks that don't have a degree in manufacturing in Germany, they go through an apprenticeship program and learn on the job, which I think, especially in our industry, is something that we need to focus on more than we do today, especially in the US.
No, you're absolutely right. And kind of an interesting point to that. So in Rochester, well, it was a hotbed, as I was mentioning, for manufacturing and contract manufacturers. It was still hard to get skilled, trained employees. And so my grandfather decided, look, it's going to be great to work with the community colleges, things like that. But if we don't take this into our own hands, it's really not going to get done at the end of the day. And so it's funny, not fast forwarding to other things we might talk about, but the number one thing when we talk to people today, they'll talk about workforce being the number one problem. What's your number one problem? Go to any manufacturing company and say, 9 out of 10 people are going to tell you the number one problem is workforce, getting skilled, trained people to come in. And so I also get a lot of people coming to us say, we need to go over to Congress and legislate something. We need to go do X. We need to go do that. And I think it's good. We should keep focusing on those things. But having now experience of seeing that from the 1970s going forward, having heard my grandfather talk about it in the years before the 1970s as he was building his business, and as I've seen in all the years while I've been running my own businesses, and then while here at AMT for the last 15 years, it's the same thing. And if you're going to wait for someone to actually solve the problem for you, the problem's not going to be solved. There's no magic Dixie dust that is going to just all of a sudden create everybody loving apprenticeship programs and doing these things that they're excited to get into. It really becomes incumbent upon the companies to actually figure out how to go grab the bull by the horn and integrate their own solution. And if it happens to be an apprenticeship program, a modified apprenticeship program, a co-oping program, if it happens to be leveraging Tooling U or LinkedIn Learning or some other online Khan Academy, find the thing that's going to work for you. Don't wait for someone to go fix this problem, because again, my grandfather was talking about it when he was running his company back in the 40s, 50s, and 60s. The problem hasn't gone away. It's always going to be there. People solve it like my grandfather ran apprenticeship programs. He'd run 2 to 3 classes of kids through programs, and he'd lose 30% of them right after training them. But he'd keep the other, 7 out of 10. And then out of that 7 out of 10, 2 or 3 might actually either get hired away by somebody else or decide they want to change. But if he kept 3 or 4 out of 10, and he ran several classes per year, he was building his own network of skilled, capable people. And many of those stayed on for long-term careers, but it only happens because you take the initiative upon yourself to go solve that problem.
I couldn't agree more. And I think also in today's world, you are less reliant on the established institutions in education, right? I think they still play a crucial role and an important role, but not the only role. And I think companies can develop their own education programs with somewhat low effort and resources internally. They can partner with OEMs such as Haas and EOS and others that have programs developed, and also collaborate with each other. I think Punko Racing is a great example. We just had them on the show last week. They have their own Punko Academy where they really have vertically integrated the whole education sector. And some of those stay on, not all of them stay on, but they are creating a huge workforce in manufacturing in their sector. So that's a huge and really good point that you're making. It's not just up to legislation and educational institutes. It's also up to us as the manufacturing industry to build up that talent and to attract talent into our industry.
Yeah, absolutely. I mean, if you can make what you do fun, exciting, if it's innovative, if you can actually pique someone's kind of interest into what this might be and why if they're involved with it, they can actually do something really unique. You're going to get people that want to come in. And so once you've got them in, now the trick just is you're pointing out, how do you give them that skill? How do you upskill them? And the trick that is available today that wasn't available 10, 20, 30 years ago, all the things you can do online with the internet, and even now, even more so with, augmented reality or things you could do with gaming or things that you can do with AI. So you have these tools now to get credentials and certifications to kind of get people qualified through different parts of their growth. And whether you integrate that into, again, a co-op of some time, an apprenticeship of some kind, you really have the tools today if you're doing something that really is going to be dynamic and interesting that people want to be involved in. And if you're not doing that, it doesn't really matter how hard you train and what you try to bring them in, people aren't going to stay at your business. So there are different components to this, but it's all things that manufacturing today, it is the cool place to be. It is the exciting thing to do. It is innovative. It is driving the overall economy. It is core, and people want to do things where they actually create something. So software was really where I wouldn't say lost, but where a lot of the really bright people just gravitated towards. But a lot of those same bright people now don't want to physically make a thing. They want to create a thing.
Right.
And I think that's the wonderful thing about additive. I get asked about additive a lot. And, sometimes at a conference or things, I'll say, I'll tell you, what the number one thing that additive done, and they're expecting a total different answer than the answer I give. I said it was creating the maker movement. I said the single biggest impact I think additives had on manufacturing, and I could be swayed to go in a couple different directions, but I say this and truly believe it. It was getting 500,000 people into a maker movement. Those 500,000 people weren't engineers. They weren't people involved in manufacturing. They weren't doing CAD development, but they found they could go get, a $1,500 to $4,000 thing. They could actually create a product. They could use their phone. They could scan something. They could create a simple file. They could load it into this machine. And all of a sudden, the thing was created. And people then looked into what's more openware that I could do with, how could I get more into CAD? How do I look with different material that I could put in this machine? Those 500,000 people all became part of our manufacturing space that in any other scenario that wouldn't have existed, that wouldn't have happened. So it's really cool. Back to this point of education, how much additive in the maker movement created a whole tidal wave of interest and potential new, bright young people coming into manufacturing.
Really good point, right? And if you look at engineering programs today, there is going to be a 3D printer at every college, at every university, period, right? And it may just be a small desktop system, but it does expose students to a different way of manufacturing and a different way of thinking, also when it comes to design and the manufacturing process. And I think one thing that's really crucial that you said is, computer science was the number one sexy thing to study for a very long time now, right? Probably for the past 10, 15 years. What I am observing is that that interest is going down for various reasons. One is just tech companies aren't hiring as many people anymore, but also you see somewhat of a merge now of computer science, manufacturing. They're coming closer and closer together. And AI is one of those really good examples where AI is not just about chatbots and image generation. It is also finding its way into manufacturing. And I know that you just a few weeks ago were at the NVIDIA GTC at their large conference. and you took away, I think, a lot of interesting insights from that conference.
Yeah.
Can you talk a little bit about what you experienced there and how AI, from your perception, is going to change and influence the manufacturing sector?
Yeah, we actually went to GTC, NVIDIA's GTC last year, and they've been on a hiatus for about 4 years since pre-COVID, so it's the first time they come back. And I went with just two of my people, and I was blown away by the level of technology, the stuff that NVIDIA was doing. I guess most importantly at that time, it was that there was a direct connection to manufacturing. And, in my current position, I've always been a techie. I've run automation companies most of my life. So I've always been like on the bleeding edge of leveraging technologies. And so it was exciting for me, but I'm always trying to figure out for our industry, for our members, like what am I going to go learn it? And why would I go to that? I just knew there might be something there. And they were just introducing the new Blackwell chip a year ago at that event, which just was a, totally enormous game changer. And actually using that term probably double for them, right? Because the whole thing with GPUs start out with these guys actually creating stuff for games, but they've been able to leverage what that really is and driving into totally changing the paradigm of what you do with computing and building out the possibility of the advanced things that are happening in AI. So this year I went back and I brought 3 board members with me because I knew there was going to be things you see at the NVIDIA conference. So what happens at the NVIDIA GTC is the big thing everybody wants to go to start with is there's a keynote by Jensen Huang, the founder and CEO. And it is like going to a rock concert. There's people lined up around the block, I would say for a half a mile or mile in every direction, trying to get into, it's in the stadium that the Sharks play in. So I think it holds like 15 or 16 or 17,000 people. And there's 25 or 30,000 people that try to come to GTC for the conferences and the workshops and all different things. And so if you get in, you get to hear Jensen. He talks on stage for 2.5 hours with no teleprompter, with no notes, with hardly skipping a beat on all the advances of all the technology that NVIDIA is steeped in, what they're doing with their technology, what sectors are there, how it changes kind of how a bunch of different industries are going to work and function. So the first part of going to a GTC event, NVIDIA GTC event, is kind of just getting this man's idea, brain input, visualization of as to where the market is going, what's going to be happening in this advanced technology. And again, getting a dose of where it's connected to manufacturing technology. And so the big kind of takeaways from my space in this, or the manufacturing space, was for them, what they're doing in Omniverse, and then also kind of where they're seeing the important crossover of their technology in robotics and robotic capability. Certainly the biggest thing overall at the conference is how AI fits in that, but AI has to be applied to something. So it has to be the application of AI to really be sensical. So when you think about doing things in an Omniverse, which we can talk about a little bit more, where you think about things you need to do to get to agentic AI instead of generative AI, so moving up the scale and what you can do with AI gets to be really important as you get into what you want robots capable of doing. So generative AI, when you talk about a robot, would be, again, leveraging AI to generate something. You put information, it generates out of what it knows certain things, certain ideas, certain videos. You can create schemes. They can do software coding for you. You could create a picture for you. You could do the beginning of a movie for you. It can generate a thing. When you take that next step, getting into agentic, essentially it's basically like functioning with agency, which is kind of where the term comes from. So it's now the AI is driving the ability for the device, or in this case, the robot, to actually move forward without any real additional human interaction. And so it can kind of think, is a very advanced word, but basically make certain decisions without being coached or supervised in the process, and seeing where this potential crossover is quickly coming between generative AI and the agentic AI and how it's applied gets to be really interesting in our field of manufacturing, without a doubt.
Yeah. So, I mean, there's now 17 follow-up questions I have for you. Well, we'll take them. We'll take them step by step. I want to dive into the Omniverse, and I'll have you explain that in more detail. Let's stay with generative and agentic AI for a second. The way that I kind of view it is generative AI requires prompts, right? Prompts for the AI to give me an output. In the robotic space, that would be very similar, or very simply to me to communicate that would be, if you've seen the figure robots taking groceries out of a bag and into the fridge, right? Generative AI would be, take this ketchup bottle and put it on the upper left fridge panel, right? And figure out how it fits in there best. The agentic AI would be, unpack all these groceries and it figures out by itself where something goes, fridge or even the pantry, etc. Is that a good understanding of how these two kind of differentiate?
That's a good way to explain it. And even just on that last one, what it would do based on its knowledge from past things, it would think that the ketchup should go next to the mustard and the mayo versus go next to the soda or the milk. You didn't have to tell it to go do that. It knew by previous inference. It knew it by collecting data of pictures or photos or videos it's seen of other refrigerators. It did it because maybe there was pattern matching from different things it was requested to bring out of the refrigerator at a different time that went for different meals. And so it would then have figured out that that's the right thing to do. Where in your first example, it would be you needed to tell it to put it where it best fits, maybe on the left door or the right door. So it essentially know what to go do. It might work on its own to figure out the fitting part. So there's certain parts of that where the AI can pretty quickly start to figure it out, but it needs direction and guidance to go do that. So that's a good example.
Yeah, pretty interesting. And if I now translate that to additive, which in certain cases is ultimately also an automated manufacturing process. Certain cases you could compare that to robotics. Maybe it is even a manufacturing robot in a if you stretch the definition a bit. How would you see AI influencing the manufacturing process? For example, looking at additive manufacturing, maybe even taking the agentic and generative AI approach there.
Yeah, when you start to take a look at a process, like with additive, you can pretty quickly start to see how you would use basic AI algorithms to figure out how to enhance performance of the machine. So it can be looking at dozens, if not thousands, of variables at a sense, let's call those variables sensors, temperature, humidity, power consumption. It can be looking at thousands of variables at a single point and at a single time. And that's again where keep the connection back to things like a Blackwell chip, a really advanced GPU, in order to be able to look at the largest amounts of data in the shortest amounts of time requires processing capability that before now we really weren't used to being able to have if they're really enormous amounts. And that's why also when you talk about some of these facilities that have, huge racks of these kinds of, GPUs, they're put into big processing centers and these data centers. And why people talk about the energy consumption, there's electricity has to go through all of those things to actually make that happen. And then there are enormous racks and filling entire buildings. And so it's a pretty big, complicated process to go do this at the end of the day. So if you've got an additive process and you now have more and more sensors built in, more and more motion control that you take a look. So motion control in the machine, you're looking at your position in milliseconds. And if you're looking at the power going into the laser, you could be even faster than milliseconds, depending on what you want to look at and what you want to collect. You have the ability to collect it. In the past, you might not have, because what would you have done with the data? Now, all of those, let's just say on an average additive machine, there is 150 sensors tracking things that are tracking them in milliseconds. To do something that actually makes use of that data, you can build an algorithm for certain things. If you know what you want to adjust because of a temperature or humidity, you can program in the algorithm to have it go do that. And it could make adjustments on the fly based on that information input and then change something to perfect or improve the process. When you move that to an agentic application, it's you essentially have then built a system that knows that there's certain things that should be adjusted and that it actually could adjust on the fly. And so in the first example, it's actually giving you process improvements you might want to be thinking about to have the operator go do to the machine based on the input of all that analysis. In the second one, it's just looking at all those things and it naturally makes the changes, and some changes that maybe you never programmed it to do. But again, it over time figures out by inference what to go do. So it's, in some cases, you do need to obviously go train it, but you're starting to separate what has to be pre-programmed in the algorithm, where the algorithms actually allow latitude for the actual system to self-adjust. Because it goes back to like considering that the machine is a robot, right? So the machine and robot, same, it's a piece of automation. You want the piece of automation on its own, figuring out what to do to make the best thing. The robot to get to the best spot, do the thing that you've asked it to go do. And these are steps down the road. It's not like we're at agentic at this point, but I think the important point, which is why, like we from AMT, I was there with my, vice president of technology, as well as a couple of my key technologists. It's for us to help figure out what is that process? Where is it ending up? What might we be thinking about? Not what we're going to go do in our products tomorrow. I mean, people don't need to go over their skis and go, oh, we're going to go do this stuff tomorrow. But you have to think about, what does it do to your market? What does it do to how you want to build a machine? What does it do to what processes you're thinking about integrating today and what platforms you're thinking about working on that will lead you to be in a position to take advantage of these things when they happen? Or if it's going to, on the other side, create a competitive advantage for someone else to take you out of business or take up a piece of your business, how do you either protect against that or get in front of it? I think that's kind of where sorting it out and talking about it today on these things that are going to happen in the future, why it's relative.
Yeah. I mean, it's such an interesting and multifaceted technology impact on additive, right? And I think especially in additive where you still today have a requirement for engineers to have a lot of in-depth process understanding in order to drive innovation, right? You literally have experts in additive, in metal laser powder bed fusion, for example. They can look at the sparks and identify that we have too much energy in the process, or we need to change the gas flow, et cetera, et cetera. Which really means that there's a lot of potential for AI to come in and make those connections of very, very complex and diversified parameters, right? We have 150 plus parameters within the machine that we can tweak in order to optimize material properties, the productivity of a system, et cetera, et cetera. And I think it's very difficult for a human to make all of these connections because there is literally millions of combinations that could result. So I could certainly see a future where a machine also by itself in a agentic manner suggests improvements to the owner, to the manufacturer on how to make this process more efficient, improve material properties, all the way to the beginning of the value chain in the material development, right? New alloy development, I think, is going to be one of those very, very interesting fields of AI implementation where creating new alloys and compositions that have never been seen before or tried out before without the need for extensive testing and designs of experiments that then, down the road with thousands, hundreds of thousands, or even millions of dollars of investment lead to the fact that this one doesn't work.
Yeah. And what's interesting relative to that is to think about, well, I think materials get to be one of the more interesting kind of growth opportunities that are really unique in the additive space. And so you start thinking about, okay, back to the AI thing, just think of all the very minutest material changes you could do and trying to figure out the impact it would have on a range of products and a range of machines for a range of applications. I mean, it's kind of mind-boggling. And then even figuring out how, let's just play in metal additive for a second. In metal additive, again, all the different powders and all the different treatments to those powders to get them ready to be put into a machine. And powders were actual materials that don't exist today. And let me make the jump then into Omniverse for a second. So if you look at, there's a company in Canada called Robotics. So Robotics is a company that leverages AI and little automation stands about the size of the table I'm sitting at here with a small robot, a bunch of testing gear, and these little cells of which they have numbers of those that are all trying to figure out how to create new elements on the periodic table. All right. So pretty advanced kind of stuff, figuring out what we may do by putting different things together to try to, and what they can do is just run thousands and thousands and thousands of cycles in every one of these little automated tabletop test beds and collect the information and let AI keep generating what they've seen happen from all the data they're collecting and integrate that next step of what you might go try. So imagine now 10,000 of those test beds, which are actually created and put into the Omniverse. So essentially, if you know all the physics of the table, so if you know the little robot, if you know what the end effector is doing, if you know the materials or gases or fundamental elements that you're using, and you know the chemistry or physics or the actual kinematics that are actually going into it, you can take this model and you can put it into the Omniverse. So you don't even need to put it in the Omniverse. You just want a digital twin of one of it. You can just make a digital twin and have it on your own. But if you want to have a whole factory of them, and there may be other things that are connected to it, you need to put it in a place where all those digital twins work together, are integrated into a factory. So think of the Omniverse of the integration of a factory of elements, machines, equipment, technology, where you can see them all operating together in this virtual world, but with the correct physics and kinematics and chemistry happening together. And so now you can start running synthetic data to try to figure out how I can run millions of cycles of things to advance out what is that next best powder that could change the entire way I make a part, the speed I make the part, the quality I make the part, or the material that we never thought we could use to actually create an end part. And you start to see this migration of what a chip allows you to do for processing, what a bunch of those chips let you do for storage and massive consumption of data, leveraging that data being applied to a digital twin that you can make by itself with the right information that's come out relative to that twin, where you could take 1,000 of those twins and make up a factory and put them into a space where they can actually operate together in the way they would functionally be operating together, to then actually watch the process or create the process to iterate certain things that happen over time. That's this migration up the kind of food chain of AI and how you would use AI to do some things we're doing nicely now, standalone, individually, kind of getting our feet wet, doing some things reasonably well, and taking it those next couple steps, and why somebody like NVIDIA would bother creating something called an Omniverse.
You've heard about the idea that we all live in a simulation. This is one step closer to proving it. I mean, it's such an interesting concept, and I haven't really dove into the concept of Omniverse, but you did a really good job explaining. It's really moving multiple different, in the past, isolated simulations or digital twins into one connected chain that can communicate with each other and figure out very complex models, such as a manufacturing floor, and optimize this manufacturing floor by really simulating the full process chain that consists of individual, sometimes simulation-based models, sometimes probably a bit more real-time data input models, et cetera, to then end up at a spot where I can increase the efficiency and optimize my complex process chain in a way faster way.
Yeah. No, absolutely. Absolutely. And everything driving around really data, right? Everything's driving around data. Everything goes back to the chip. And so, good data if you understand your machine, your equipment, if you understand the physics, you can actually build things and then the nice thing is where you're off a little bit, you can keep collecting data on real equipment by adding more and more sensors, more feedback. The more feedback makes for a better model makes for a better twin makes for a better integrated digital factory. Digital factory allows you to do things to make sure when you're doing it for real, that you're using the best layout with the right solution set to get the most productivity before you waste a lot of time and money on capital or training or facility layout or material purchases. Think of the days when we would have to prototype everything. One of the industry that's kind of gets affected a little bit is if you were building little functional prototypes of things. And, there's always going to be some of that because time is going to be of the essence. You're not going to want to mess around in certain places, but a lot of building out and figuring out like non-destructive testing. I build a 6-cylinder engine, and I want to see at what point, what RPMs I can run that with very little oil before the thing actually seizes up, and then work backwards. What actually happens? What can I do about it? Well, building up an actual 6-cylinder engine and doing that in a facility is extremely expensive and, uses a lot of time. Imagine if you could have the information, build it into a model, and functionally run it with 1/3 the normal amount of oil, and actually look for the failure points and get solid information out before you actually burned up any metal, machined a bunch of, crankcases and housings and pistons, and actually could do it right the first time out of the block because you did that work ahead of time. So look, we're a ways away from those things, but it's not like we're talking about things 10 years away. We're talking about things that are in a 2 to 3 year window of being a little bit more commonplace. Does that mean every single shop, is doing it? No, but it means many different companies and organizations will be able to leverage tools like this to kind of build out and apply your talent then to getting that done where you maybe don't have as many people that can actually construct that actual physical thing on the floor. Well, okay, the good news is get people that understand some of that, let them understand those things, let them work with the data, work with the system, and then backtrack with engineers the failure points and what we might do to improve those with design engineers and things. So it changes the dynamic of where you apply your talent in a facility or a factory or a lab.
Yeah, it really allows for various size of organizations to streamline their processes, not just for the biggest players with the biggest resources. So there's also an aspect of democratization of resources that were typically only available to the largest manufacturers.
Yeah.
Which should therefore make supply chains way more resilient and responsive than what we see today.
Right. And that's exactly right. If you want to move the whole industry forward, you got to have something that the most people can actually leverage and use. And I think we've really gotten to that point in a lot of different ways. The price of sensors, the price of robots, the price of most machine tools and additive systems, software platforms. And you look at the price point for any of those devices compared to what they would have cost in the 70s, 80s, 90s, early 2000s, it's dramatic. The level of quality and reliability for all those things I just said at 1/4, 1/10, 1/100th in some cases, the price point. So it is getting to where it is exactly what you said, Fabian. It's more the democratization, a lot of the manufacturing technology, which can be deployed by a greater subset of the manufacturers here. And then basically then leveraging the productivity and ability to get more products and more people at a price then that is more functionally usable or acceptable for them to do whatever their next step is. So for the OEMs of equipment technology to get that to their customers, for their customers, whether they're making planes or satellites, you're making cars, trains, you're making communication devices, doesn't matter. All those things, you can make them faster, you can make them better, you can make them, more functional, they're lighter weight, at a price point that more can use them and kind of build out their market. So it's good on all fronts. And also there's a lot that gets focused on how do you do it with less energy? How do you do it with less material? So the whole waste sustainability component comes in natural without saying, I'm doing this in order to be green. And I think sometimes when you do that, people just say the words without really knowing what they're doing or how to do it. I think any business tries to do things at lower cost to create better value. And if doing that, you can do it by absorbing less energy, which lowers your cost to make the product or lowers the cost of the person who you're selling it to keep on having a lower level expense. That's a sales feature. That's a cost feature. By focusing on doing those things, lightweighting in order to make the aircraft use less fuel. Okay, if more people buy it, you get more revenue. More revenue means more R&D. Yes, you get to a greener place and you want that to happen. But instead of it being just kind of a lip service trademark thing, you're doing it because it's the right functional way to move your business forward. And it's the right solution for the overall environment at the end of the day. Comes along for the ride without it being forced on people to actually do it. You do it because it makes sense to go do.
Yeah. We're entering a world where the actual output of capitalism is a more sustainable and resource efficient world, right? Which is good for all aspects of human society.
Yeah.
One thing that's interesting that you also mentioned early on is robotics, and that's interesting from an additive perspective, but also just in general from a manufacturing perspective. And of course, here, if you've seen pictures of the NVIDIA conference, there were probably dozens of robots on stage. Various different announcements from that space have been in the news recently. Right, one of the top players, Figure, recently announced that they moved their timeline up by 2 years of even introducing humanoids into homes. Companies like Apprenticeship here in Austin, Texas, they recently finalized a large funding round, also with large partners like Mercedes. So there's a lot of momentum in that space. I'm curious to hear your thoughts on what that means for manufacturing. And also, what that means in general for the general workforce out there, right? Should they be afraid or should they be embracing robotics?
Yeah, I mean, I'll do the last part first. I think you definitely want to embrace it. It's just like almost every other technology since the beginning of the Industrial Revolution. Everyone said back when we were farming with horses and plows that, if we went to these tractors, there's going to be no farmers left. We won't be able to have anyone, create food products for us. And of course, we know what happened with that. I mean, so on and so forth, all the way through every single decade. So people realign to the thing that creates higher value and is better places for them to work and safer, cleaner, more interesting, innovative environments. Same will be true when it comes to what's happening with robotics at the end of the day. And more job will be created because of the need to develop, expand, leverage what you can do with robotics than the number of positions that are going to, take over because of the robotics. So in the two spaces of robotics, I guess it's easier just to think of them in two huge or main categories. So we'll call traditional industrial robotics, and we'll call the humanoid robotics. At some point, those two will merge. It'll be out in the future. I think it'll be out in the future a little further than some of the commercials would have you believe, but out in the future. So in each case, there's plenty of work going on to leverage, grow, and take advantage of sensors, vision, the size of the actual robot. A lot of the big money and a lot of the attention is going to humanoid robotics just because it's very sci-fi. It's very what people's brains get to. So when you look at a KUKA or a FANUC or an ABB welding robot in a factory, people aren't thinking Star Wars or thinking about their latest TV show, Westworld or whatever else, right? You're not thinking that. You're thinking, okay, there's a factory with robots doing stuff. Great. I don't want to be welding. That's cool. But even the technology that those people are using, those companies in driving AI into those processes is changing. So there's just as much NVIDIA, like horsepower, let's call it, going into getting those companies to be more advanced with what they do with the industrial sector is there is over here in humanoid. Humanoid is interesting because it is that next evolution. And some people will go, why make robots for industrial applications that look like humans walking around? And I think there's lots of good reasons for doing that. If you think about, the vision for a robot. So, you essentially are developing higher level sensor capability that can immediately work with the CPU to connect what the camera is seeing and interpret that. That process is handy not only what's happening with the robot, but it's happening with autonomous vehicles. It's kind of useful when you think about humans that have lost an eye that need to have a replacement. So there's a medical way, and it's true then for all of the parts of the humanoid robot. You lost an arm, you lost a leg. Hey, you know what? Because we're doing humanoid robotics, we figure out how to do that configuration. We figured out joints and angles and articulation. Humans happen to be particularly good because of all our digits and joints and angles of actually maneuvering and getting into spaces and picking things, moving things, and thinking about them. So all the major things you'd want your industrial robot, no matter what its size configuration, it only makes sense to make it close to human, because the easiest thing for people to do in a lab is emulate something they know something about and then accelerate, make it better. The nice thing about also doing it in a human size package, i.e. a humanoid robot, is you've got to start thinking about space requirements. There's only so much space to do, building the actual motion device and actual components you would put into all these joints and motor control. Size is a huge issue. So miniaturization is really key to get all these things to fit into the size configuration of a human body size. So you notice none of these humanoids they're making are 12 feet tall and 4 feet wide, which would be the easy way to actually get all those devices to fit. The other thing that becomes interesting about a humanoid package in this sense is energy. You got to figure out how to have every one of those motors, drives, that's actually articulating and moving all of those different, joints, not consuming an enormous amount of energy, because the battery pack would need to be the size of half a room. And you won't be able to have the robot walking around very long if it's carrying, 500 pounds of battery. So it drives an efficiency factor for energy consumption, and also drives development of battery technology to be enough that it would just be like a backpack on the robot that can have it work for 8 hours without having to go charge in the wall, because depending on what application you have it in, you can't just go plug it in every 2 hours. It becomes pretty useless. And so that configuration, that space gets so much attention because of all those reasons. What you can do from a medical standpoint, what you can do changing the vision component, the size of components, miniaturization, leveraging storage technology. And so all those are pretty neat things in the humanoid space, which is why it gets so many venture capitalists and excited, because all the collateral industries that are affected by what I just said are investment opportunities for people. And at some point when you got, some of the major corporations actually getting all into robotics, it's going to be the folks at Amazon with robots. They're going to be the folks at Tesla with robotics. And in the last year or two, Caterpillar's bought a robotics company, and John Deere bought a robotics company. So two people, I'm just picking out of an industry that you wouldn't expect to be in robotics. Everybody's getting into robotics to some extent. So there'll be things developed in the industrial side, humanoid, a little bit further out there, but most of the money and focus is on that. But that one's a little bit further out before it really starts to translate into things we're going to be using in our manufacturing space.
And also, one thing that I really noticed in what you just said, there's also, again, here, a merging of industries around this one sector, right? The medical space putting more and more into also and leveraging humanoid developments. You could see care also leveraging humanoids more and more. And one thing that's also, I think, or two things that stuck out to me. One is, people forget that humans are the most efficient species on the planet, right? Cheetahs are the fastest. Elephants are some of the strongest. But over, a 5-hour window, the humans will lead. So therefore, we are a very, very efficient design when it comes to energy efficiency. And we're also somewhat versatile, right? We can work with our hands on very precise watchmaking devices, but also in very strong and other more conventional manufacturing environments. So therefore, it is a pretty good design that is also accepted, right? Yeah. If you see a humanoid robot that kind of looks like a human walking down the street, you may actually wave. And if he waves back, that's when you get your first "oh shit" moment. But you'll get used to it pretty quickly.
Yeah.
Right. I was recently in a self-driving vehicle down in Austin. 5 minutes were weird. Then it was kind of normal. Right. So if we know things that become automated, I think the adoption is a bit easier versus something that looks a bit scary or unknown.
Exactly right. Totally agree. And I think, anthropologists would be saying the same exact thing. Hey, we didn't get refined to this point not to leverage what's been 1 million or 2 million years of actually working on the model. So let's go use that before we think of the hours you'd spend trying to go, I'm going to spend the next 2 years coming out with a better version. Like, hey, use those 2 years just to go work with the one that we've already got. You'll probably save yourself 2 years of time.
And nobody wants to see a spider robot running around, I think. Now, obviously, we're on the Additive Snack Podcast, and I'm always super interested in, how can we help with additive to get some of these new industries off the ground? And to me, industrial robotics already today leverage a lot of additive manufacturing for different gripper types of applications. We see that more and more. But I'm also convinced that in the humanoid space, additive manufacturing can help these companies to get their products to market faster and to optimize manufacturing. You also, you have been in additive manufacturing for actually quite some time. If I remember correctly, you were an early adopter in one of your previous companies of additive manufacturing. So you have I think a really good understanding of the capabilities of the technology. Where do you believe additive can have a role in the manufacturing process of these new generations of robotics?
Yeah, it's one of those ones. Yeah, I got in probably way too early, late 1990s, so a little bit early on in the process. But I think it's a couple different places. I think form factor is a huge issue when you start talking humanoid and robotics, right? And I think one of the things that is, I think, most loved by everybody relative to additive manufacturing is this ability to rethink form factor and design. I mean, when you're thinking a prismatic part that needs to be machined, you kind of get stuck in a little bit of an envelope of what you can get away with. And you don't have that restriction. I think also multi-material gets to be really important. I think there's multiple different applications depending on tensile strength, flexibility, heat factors, where multi-material will get to be kind of important. And again, the size and the space of certain things have to take place. And that's another thing that additive allows you to do that others don't. I also think then we start talking about, being able to move into different epoxy, resin, material types. There's all of the outer parts of where these robots are interfacing and, their overall structure that can be quickly fabbed up in additive processes. It would be difficult to go create in other processes. So, there's just a lot, I think, when it really comes to also quick adjustments with these things. There's going to be lots that's going to happen for early renditions of these. Things when they actually apply the robot and put it actually into a facility next to doing a function, that they're going to realize certain sheathing or shielding, certain ways that degrees of axis of certain motions in certain situations, actual give distances between different points. Things are going to require some fairly quick readjustment, remanufacturing. And it's by far the easiest way to go do that. There's probably very little that you couldn't actually do except for the real motion control elements that are going to largely probably be made in a more traditional manner. But everything else that goes into that type of a humanoid robot, additive is going to, I think, be the way. And I think even, at that period of time at scale, I think we're really starting to bridge this gap between the concept of it's only a prototyping tool to it really is a production ready tool. We're trying to make that point back. You talked early on about IMTS, and just in case anybody was going to hold you out to what you said about the site, we're IMTS is the largest trade show, manufacturing trade show in our hemisphere. So it's pretty close, but just in our hemisphere. So you had a pretty close half globe right. But we're going to be looking at, how things like the additive pavilion should be more integrated into the main parts of manufacturing. People can actually feel, see, compare that it's not a specialty thing so much as is another tool in your toolbox to make things, and allows you to do creative things that no other current technology lets you do, which is why it's a nice collaborative tool. It's not the tool by itself, it's the tool in the toolbox into that or other thing we were talking about in your Omniverse of virtual solution. You're bringing lots of things together to solve a problem in an overall manufacturing facility. Not many people that buy manufacturing equipment have a single machine of a single type, and that's all they have. They have multiple different types of tools or technology to create end products for an array of customers in a certain field. And additive has become, I think, a core part of that, and not limited to just making part of the solution. In many cases, making all the solution. It can do, in many cases, net final application in certain situations, if you're talking metals. But that's not true necessarily in certain cases now when we're talking about things that would go into the robot. I think you could actually get to some situations where many of the things could be actually net finished right out of the additive process and used in many robot areas. So it really is an accelerator. And I think we're going to be able to shorten the time, lower the cost, lightweight the actual final product, and turn out more iterations of those products in shorter periods of time in order to advance what happens with robots in the facilities. And, eventually for home use or hospital use, medical uses, all those also come along for the ride.
100%. Yeah, I could see very similar applications, right? Accelerating time to market by using it as a development technology and as a production technology. I could see, structural components like the leg bone that also oftentimes need some thermal management integrated into it, cable channels, etc. These are very complex geometries that I'm certain in significant cases, additive may be a viable, if not better, technology to produce these in the long run. And I could also see the topics that you mentioned, right? Lightweighting means more range, means less charging time and more utilization of my equipment, of my humanoid, and so on and so forth. So there's hopefully one person out there in the robotics space listen that will think about additive manufacturing a bit differently and how it can enhance humanoids, because I 100% believe it will.
Yeah.
Okay. Now, before we talked, I also learned that you were traveling all over the place recently, from I think Europe to the Asia Pacific region and back. And we're in somewhat of a time of geopolitical shifts, right? We have just recently, yesterday, I think, announcements of 25% tariffs on the automotive industry out of the US. We've had reshoring conversations for quite some time now for various reasons. We've had various disruptions over the last 5 years in our supply chains, from COVID to the Ukraine conflict to the Houthis attacks in the Red Sea, and the list can go on all the way into natural disasters. So, can you give us a bit of your point of view of the current state of reshoring manufacturing, shifting global supply chains, and really how manufacturing companies out there can prepare for a more localized production approach?
Yeah, it's one that seems like it's this enormous thing, hard to boil down and figure out, but it turns out it's actually kind of practical and not necessarily that hard to really get your arms around. So if you think about it, I think the easiest place to really think about it is to think about the reshoring as the core thing is happening. And so it was always going on now for a better part of a decade. We kind of thought we could ship everything someplace else and cheap labor was going to be able to make it and just bring it back. And of course, it had hundreds of things that were wrong with that. At the end of the day, any place that you ship it to, eventually all their labor rates go up. And at some point, it's mano a mano, and you really didn't save that much. And oh, by the way, you've got to ship this stuff halfway around the world, which costs a lot of time, uses a lot of energy, has a lot of backlog, cash that's being used up, doesn't make a lot of sense. And so fundamentally, reshoring was happening well before what happened. And we'll say COVID was kind of a turning point. So COVID really made the entire world think about, what if I can't get things? The issues in the Middle East, the issues in Ukraine, the issues in the South Pacific, South Asia, we should say, those spaces that just accelerated the need to really look at what's already pretty commonsensical about continuing on that reshoring. The fundamental thing that the U.S. has going for, where there's certain things we clearly don't do right, and there's some things we obviously do right. We're the number one consumption place in the world. So if you want to be doing business and you want to save shipping your stuff, or you're worried you won't be able to ship your things, if you want access to the market, it makes sense to set up your company where you're closest to the end user and not ship your thing, especially if it's a big thing, all around the world all the time, either because of an energy issue, a time usage, a cash usage, or because of geopolitical issues, maybe you just won't be able to. And so that's really driven the foreign direct investment, which we continue to be the number one place in the world with foreign direct investment, and reshoring continues to scale at an increasing rate. Now, tariffs, which are all the news, of course, in the last month or two, and I bet you they'll be in the news for a while, but I think it'll actually dissipate faster than people think. It's a way that the current administration is going, how do I accelerate that idea? I want more automotive plants here in the United States. I want more pharmaceutical companies making things here in the United States. I want more chip manufacturing here in the United States. So you can either do that by an incentive. It's like the stick or the carrot, right? And so, the CHIPS Act was an incentive. Hey, we'll give you all $50 billion if you set your plants up here. Well, you'd be an idiot not to go do it, right? It was like, okay, great. I was coming here anyway. I'll take your $50 billion. If people weren't coming here, which then you want to get more of them to come do that, you create kind of a disincentive to not do it and make your product someplace else. And so you're trying to force the come to where the marketplace already is so you don't ship your product, leverage our resources here. The other thing America's really got going for it is energy. That's core to making anything. So that's a real benefit. What we lack, but at least for an industrialized country, we have a positive birth rate, but we still could use more workers. It might be hard to fill all the open spots. That goes back to our automation conversation. Yeah. We actually don't have enough of the people. So I think that starts to settle things out. And hopefully there's a block in Asia, a block in Europe, a block in the US that frankly does similar things. Like make things in the spot where you're going to go use them, leverage the best tools and technology and resources in that place. And that the things you don't have, trade with your buddies, whether your buddies are in Asia, your buddies are in the Middle East, your buddies are wherever, trade those pieces you don't have. And hopefully that creates balanced trade and not just proportionate trade. That's the idea at the end of the day. It's really reshoring on steroids and excelling. It'll take a while for it to equalize, but long term, it does make sense to do it, whether or not the tools and methodology and the way it's being communicated are not exactly seamless. But the fundamental concepts make a lot of sense. You just think practically about making things that are complicated and then having them in ships and boats and planes instead of making them where you're using them.
That was a very good summary of what's going on and the reasoning behind it. And I agree. I think the whole topic has been politicized in various countries, also in Germany and in Europe, and of course here in the US. But it's a trend that's been going on for quite some time now. And I think many countries have realized that outsourcing everything is not the way to go. And I think it should be in the US bipartisan, and in other countries a multi-partisan approach, because it actually plays into many challenges that we've been talking about for quite some time now. You mentioned sustainability, right? If I make parts locally, I reduce all the waste and pollution that happens from shipping something all over the place, where I could just make it locally. So I think that does make a lot of sense. And as selfishly, for the additive manufacturing space, I think additive manufacturing is not the only solution, but definitely is a solution in the reshoring conversation. And I think we see that very interestingly being played out by the US Navy, for example, which has realized, right, since the 60s, we have lost all of our casting houses in the US. How do we make casted parts? Well, additive seems to be a viable technology. The material properties exceed casting, I am way more flexible. I can now print in the same materials like copper, nickel. Let's do that. Do you see a similar trend where technologies like additive, but also automation, are really key to bringing manufacturing back to where the demand is located?
Yeah, no, absolutely. I mean, you think about it, countries can only create value is only created one of three ways, or all three if you haven't. You make it, you got to mine it, you got to grow it. The only ways you create value. Otherwise, you're just swapping paper back and forth, and there's no value creation. So when you look at that, and as you point out, additive lets you kind of do that even more readily. I think that becomes really evident when you think about now the naval ships, to your point, that have additive on board to do things. Think about the space lab that has additive equipment in order to make something or test, could you make something in space? If they go put something on the moon, they will have additive equipment there to actually do things they're going to go need. So additive is a perfect example of take the thing that makes things, put it where you need it to make the thing, and actually you've got what you need. Now, it's an extreme example in those ones I just mentioned, but it really sets the picture for it. What we've been talking about earlier today is the advancement in price point, the democratization of automation and robotics, the leveraging of the size and weighting of these different tools and techniques, that you could easily see how you would go put form-fit manufacturing facilities in different places. If you look at some of the things that Foxconn or Proto Labs or Jabil are doing for creating massive manufacturing companies, you could see a network of these manufacturing facilities that could be stood up in different places to make different things and interconnect and leverage the data and information they're getting from those facilities to be highly productive. You could integrate a chain of secondary and tertiary contract shops into partnerships with those major players and see a web both in, North America and Europe and Asia that are leveraging similar types of webs from major players of people that are in that space. The tools, the price points, and the ability to get highly reliable technologies in these spaces really lets you manufacture at scale at price points that match chasing low-cost labor around the world. And I do see that is how this will be built out over the next decade or two. It will be clearly how it happens, and that what you'll be trading is what things you don't have, right? We're going to trade, our energy for somebody else's titanium. Someone's going to be trading one food substance for a different type of pharmaceutical thing. That's how the trading will take place. But most people will be doing most of their manufacturing technology in their core areas, leveraging these types of technologies.
Super interesting. It dawns on me that actually ties our whole conversation together quite nicely. The democratization of new technologies, right, such as robotics and additive manufacturing, through not only the accessibility of complex compute, but also the reduction of the barrier of entry into those new technologies, right? Because I really think that if you need a PhD to implement additive manufacturing like 5 years ago, that barrier of entry is really high. I think already today we're at a point where we can train somebody in a week to leverage additive, and in 4 weeks on how to design and prep data and post-process for additive. And that barrier is already way lower than it was 5 years ago. Now, if we now leverage artificial intelligence, like you mentioned, for full process control and qualification, that barrier is really non-existent, and therefore allows small and medium enterprises, not only the big Jabils of the world, but the small machine shops, to implement new technologies to give them a better edge and competitiveness in the market, and really position themselves as an equal player compared to the big guys that are really dominating those advanced manufacturing spaces today. What advice do you have for those companies and individuals out there that are trying to understand, how do I now take the first step? Additive is new, AI is new, the Omniverse I just heard about for the first time, and then the humanoids are coming. How do I prepare myself in a realistic way for that new wave of manufacturing, and to be a part of the reshoring efforts to bring back manufacturing to various types of countries, such as the US, such as Germany, et cetera, et cetera?
Yeah, I mean, I think some of the best things you can do is really a little bit of learning and absorption. And so it's like, where do you go to kind of do those things? And so, depending on what field you're in, if you've got a good trade association that, is doing a lot of that work, is out in front of things, go leverage that. If you've got a good technical university nearby, there's probably programs and things doing there. If you're near one of the manufacturing USA centers, innovation centers, those are great sources of information as well. When you start to actually then look and go to trade shows, I mean, we talked about trade. There's trade shows all over the world. There's regional ones. There's big ones like what we do at IMTS. We bring a lot of together. I mean, go there and see the different things, ask the questions, look at people that are integrating those elements. Then when you get into your own plant, I think the trick is it's this fine line between, don't try boiling the ocean. Some people get all excited about robotics or AI or additive, and they want to go buy a bunch of stuff, and they're buying the stuff, not solving the problem. If you really want to be good at making sure you leverage technology, figure out what are your biggest problems, take your three biggest problems, write them on a whiteboard, get people to agree, yep, those are our three biggest problems, and then figure out what technology can be applied to those problems to solve the problem. And then go after a test example of your worst case, or one that you've got a passionate person out on the shop floor that if you give them that tool, they'll be a dog on a bone taking care of it, and then let them go run with it to solve the problem. Once you start to have the problem being solved and people see that it works, you can start to then expand and scale that, whether it's robotics, additive machines, a piece of metrology equipment, new materials. It's really a way of incrementing your way in. And so it's kind of this learn by talking to people, seeing it, going out there, getting your problems identified and applying an existing technology to it. And then what I just recommend to people, I've used it over my career, is pick one area that you think is a real extreme. Don't bet 90% of your capital expenditure on it, but take 10% of your capital budget and go take something that pushes the envelope that would totally change the dynamic of your company, that you think is edgy out there, you're not sure. And you're going to pick one every once in a while. Whether it's a new way of applying additive equipment, whether it's a modification you work on with your partner making materials for you, whether it's a new type of sensor or simulation methodology, pick something that doesn't basically bankrupt the company if it doesn't go right, but lets you push the envelope in a way that sets you apart from everybody else. There's only three places you can be when you run a business. Either you're small and you're trying to do something that's unique with really good margins. You're large and you actually pick things that can scale, and you can actually scale and get large volume contracts, or you're somewhere in the middle. In the middle is a place that can be really risky because now you're fighting against everyone else. There's nothing unique. Your margins are average. You can't get a lot of money for R&D. You got to pick what spot you're in. If you want to get out of that middle spot, you really got to go, what's going to differentiate me from everybody else? And using a little bit of your cap spending, pushing you just over the edge, you can find that unique opportunity. So that's kind of how I've seen the best of best people do it. You can look at top shops and top businesses, see how they actually do it. All top shops and the top shops analysis that the Gartner Business Media people do every year, the number one thing that's in almost every one of the top shops that comes out the best in their overall ranking is people that actually spend on new capital technology. They're buying advanced manufacturing technology and moving their business forward. Differentiating factor for almost all of them. And some of those might be a 5-person company, or it could be a 500-person company, but that metric doesn't change. So that's how I would be telling people, boy, if it was me going back doing it tomorrow, that's what I'd be doing. If everybody I've seen doing it, that's how they do it.
Great advice. Great advice. Reminds me of, I gave a talk 4 years ago, and I called it From Challenge to Challenger. And I think that kind of plays into the same approach that you just mentioned. Pick a challenge of your organization, use a new technology to not only fix that challenge, but use it to become as a competitive advantage in your field of business. And then the other thing I kind of heard from you saying is partner. I think partnering with other companies, either in your space or that are complementary, I think is also always a really good idea when it comes to implementing new technologies and learning from each other.
Absolutely. Yep.
Well, Doug, it was a delight to have you on the show. We went everywhere from AI to robotics, all the way into the geopolitical challenges and opportunities that we're facing today. I learned a lot. And I'm sure our audience also learned a lot. So thank you for being on Additive Snack today.
Thanks for having me. It was a great chat. Love doing it. It's great that you get this kind of message out there, and I'll be tuning in for future episodes so I can keep learning from you.
Awesome. And I'm learning every time we have awesome guests like you. And I hope you out there also learned a lot today from my conversation with Doug. If you like this episode, share it with a network, a friend, a colleague who has those same challenges as many of us and is trying to find their way through all of these new innovative technologies. This was the Additive Snack Podcast, and I will see you next week.